Now this will be third video on properties of eigenvalues and eigenvectors, and we will see property number 12. If a plus ib is an if a plus ib is an eigenvalue of matrix A of matrix A, then it's compulsory that A minus IB is also an eigenvalue of matrix A. Now properties number 13. The eigenvalues of a real symmetric matrix or a Hermitian matrix are always real. Properties number 14. The eigenvalue of a skew symmetric matrix or a skew Hermitian matrix are either 0 or purely imaginary. Properties number 15. The eigenvalues of an orthogonal matrix or a unitary matrix have absolute value. That is lambda is equal to 1, or we can say this as length of lambda is equal to 1, where mod lambda is equal to 1 means the length of that eigenvalue is 1. We will take example. Lambda is equal to minus half plus I root 3 by 2 can be eigen value of unitary matrix matrix because if we calculate length which is lambda, mod lambda is equal to half whole square plus root 3 by 2 whole square is equal to 1 by 4 plus 3 by 4, which can be written as under root 1. So finally we get mod lambda equals 1. Length of mod lambda is equal to 1. That's why we have to remember unit circle concept whenever if we have any confusion in the case of Hermitian, skew Hermitian and unitary, we will use circle concept. Circle concept. Unit circle, unit circle, or we can write mod z is equal to 1. Length of mod z is equal to 1. This is our circle. We have a circle, and these lines represent Hermitian or symmetric, and these are the intersection point. Intersection point will be 1. This will be I, and -1 and -I. Now this line will represent imaginary line, and this line will represent real line, and this line will represent our skew symmetric or skew Hermitian. So we have to remember this concept, and this will be 0. Now we will see properties related to this circle concept. It will be property number 16, where it will be eigenvalues of symmetric and Hermitian matrix are always real. Those eigenvalues always lies on the real line. So we had real line as this was our real line. Now we will see property number 17. Eigenvalues of skew Hermitian and skew symmetric are always imaginary and lies on the imaginary line. We had imaginary line. This is our imaginary line. Now 1 and -1 can be eigenvalues of Hermitian skew Hermitian orthogonal unitary matrix. So eigenvalues of orthogonal and unitary lies on unit circle. One more conclusion we can draw. Modulus of lambda is equal to 1 means magnitude 1 all the eigenvalues lies on the unit circle.